All right, Math 136 students, this is from the section on transformations of functions. This is a specific section of, we're just going to be looking at how do you describe a transformation of functions from what you see. So if someone gives you the function and they say what transformations have occurred, the guidelines that we've listed here will help you to write that as a sentence. So the vertical shift and horizontal shifts are our first two that we're going to talk about. And when we talk about the notation, there's always a parent function that we're transforming. So we're calling the parent function in all of these f of x. And what happens is that there's other things going on besides just that parent function. If something happens on the outside of the function, so let's say your function is absolute value of x. Well, if you throw on a plus 2 at the end of that, that's happening after or outside of the absolute value. So if something happens on the outside of the absolute value or the parent function, because it could be other types of functions as well, then we know that it's going to affect the y variable of that function. If something happens inside the function, which is like the horizontal shifting problems, it's going to affect the x variable. So look at this first one. It says that whatever our parent function is, whether it's an absolute value of x or an x squared or a cubed root of x, they've added a constant or subtracted a constant at the end of the function. So this is not in the part that has the squaring or the cubed root or anything like that. And if you have a plus k at the end, then your parent function will be shifted up k units. If you have a minus k at the end, your parent function will be shifted down k units. And up and down affect our y output, so that is affecting the y variable. If you have something inside the function, so notice this next case, the horizontal shifts, the minus h or plus h is inside of the parent function. So this would be like having absolute value of x minus 4. So notice that was inside of the absolute value. Instead of saying absolute value of x and then a minus 4 at the end. So it is different. And then when you have something happen inside, we said it affects the x variable, and it actually does the opposite of what you think. So if a parent function is shifted h units to the right, it was a minus h inside. And if you have a plus h inside, the parent function will be shifted h units to the left. The other types of transformations that we encounter are reflections and stretches and compressions. So if you have a negative, and this could have a number attached to it too, but mainly because there's a negative sign in front of your parent function, so it's like -1 times the parent function, then that means you're going to have all of your y values, since this is outside of our function, are going to change signs. So that makes the whole function flip over the x-axis. If the negative is inside the function right next to the x, then it is going to make it flip across the y-axis. It's going to change all of our x signs, which means we flip horizontally across. Vertical stretches and compressions and horizontal stretches and compressions also have to do with whether or not something is inside the function or outside the function, but there's a second condition as well, and that is what kind of value is it? So if you have a number in front of your function, like a 5 or a 7, and that number is bigger than 1, then that means your parent function is going to be stretched vertically by a factor of that number. So if it's a 5, then we'll be stretching all of our y values by times 5. And if the number in front of that is like 1/2, which is between 0 and 1, then your parent function will not be getting bigger vertically, it'll actually be shrinking. So we call that a compression. So it'd be shrinking by that factor of a. In other words, all your y values would be half of what they used to be, or a third of what they used to be. And then horizontal stretches and compressions are when that coefficient is inside of the function, right in front of the x. And the same rules apply, but remember, it's opposite to what we think when something happens inside the function. So when a is bigger than 1, that actually is going to make our function compress or shrink horizontally. And not only that, it does it by a factor of the reciprocal. So if this is a 3, it's actually going to be shrinking or compressing it by 1/3. And then if it's inside and the number was originally between 0 and 1, so say like, a half, then it's actually going to make it the reciprocal of that, which would be 2/1. So it's stretching or making it longer horizontally by that specific factor. So all we're doing in this example is we're going to just describe what we see in the function and write it as a sentence. So that's the whole idea behind describing the transformations of functions. So if we look at this first one, it says that g of x equals 2 times a parent function of f of x. We don't even know what it is. We just know that's the parent function, minus 5. Okay, so the first thing you have to determine when you're going to write these is you should determine what order you should be writing the transformations in. And the general rule of thumb is whatever's closest to x is going to be written first. So if there's a coefficient in front of it, or there's a negative sign next to that x, or if there's a plus or minus something in there, you rank those into the order of what's the closest thing to x. Then we would do any multiplication connected to the parent function, and then last we would list the vertical shifting. This just gives you a nice order of operations that you can also follow when you're graphing. So there's nothing really happening inside to this x, but there is a 2 in front, and that is bigger than a 1. So 2 is bigger than 1. So notice if it's in front of our f of x and it is bigger than 1, it is a vertical stretch. So that means that we are vertically stretched, and this is just kind of my shorthand before I write my sentence, by 2. That's our factor. And then at the end, we have a -5, which we learned is a vertical shift down 5. So I need to write this. So this would be the closest to f of the x, which is the f of x function here, and then this one's would be done last in the order of operations. So we would say the function g of x, because that's the new function, is f of x stretched vertically by a factor of 2. Sorry, my pen was lagging. Then shifted down 5. Now you could say shifted vertically down 5, but that's kind of, vertical is up and down, so you don't really have to say that. You could say a vertical shift down 5. There's a couple different ways you could write that. As long as you've got the context correct, that's the big deal. So let's look at number 2 here. This one has a couple things going on. There is something added or subtracted inside the function. So we know that we are going to have some horizontal shifting there. And we also have 2 things happening out front. We have a coefficient, we also have a negative. So the first thing would be what's happening inside next to x. Since this is a +1, we know that that's going to be a horizontal shift, and we do the opposite of what our instinct is, which is pluses to the right, so we're moving this actually to the left. So this would be left 1. So that would be my first thing. You could do these in either order. So if we do the 1/3 next, that would be 2, because they're both being multiplied times the f of x. So this would be 1/3 in front of our function, falls into this category where it's between 0 and 1. So we're compressing vertically by the factor of 1/3. So compress vertically by 1/3. So that's just my shorthand. And then I have a negative in front of that. So that's going to be a reflection, and because it's outside of the function, it's across the x-axis, which means all of our y values change signs. So for this second one, we would say the function g of x is f of x. First thing was the horizontal shift. So shifted left 1, then compressed vertically by a factor of 1/3 and reflected over the x-axis or across the x-axis. Okay, and then the very last one here, this is again g of x equals f of negative, and we could rewrite that if it helps. That is a -1/4 times x. The 1 is up there with the x. So this has 2 things. It has a coefficient inside the function, and it also has a negative inside the function. So if we do our coefficient first, this is inside the function, and it's between 0 and 1. So this is a horizontal stretch, because remember, it's going to be the reciprocal of that. So this would be a horizontal stretch of 1 over 1/4, which is actually 4. And then because there's that negative inside, there's also a reflection over the y-axis because my x values are changing signs. So the function g of x is f of x stretched horizontally. And you do want to put the horizontal or vertical when you talk about stretching and compressing because that is directional, whereas up, down, right, left are already kind of telling you if it's horizontal or vertical. So this is stretched horizontally by a factor of 4 and reflected over the y-axis. Okay, that's the end of this video. Hopefully this will help you guys with describing transformations of functions.